Stephen Aitchison once said that honesty has a power that very few people can handle. And honestly, those very few people are probably in the science world, because in science, it's very important that you report back your numbers with accuracy and with honesty. And when you don't report your numbers back with the right significant figures, it can almost be akin to lying. And so that's why I picked the topic of significant figures for my oral presentation for this chemistry class today, because I believe significant figures are very important when you're trying to be honest in science. With that, I'd like to actually examine two examples of why significant figures are really important. The first one is this ruler and pencil here. So we have our pencil, we have our ruler. The mission objective here is to figure out how long the pencil is. Now, looking at this ruler, you'd probably say it's about 16. My personal opinion on this is that it's 15.9. I think it makes it almost a 16, but not quite. You can have your own opinion on that, though, so you could totally say it's 16 if you want. However, when we report back our number using this ruler, what do we report back? Well, the rule of thumb here is usually to report back the number that is half of the marking you have on your instrument. So looking at this ruler, we have centimeters that are 1 centimeter apart. And so that means we can report back the number of whatever's in between. So we could do, let's say 15.9. And that is what we would report back when looking at this ruler specifically. So I'll make a note of that, 15.9 centimeters. Let's look at a different ruler with the same pencil. Now, I didn't get the same image over here. Let's just assume that the pencil carries over here. Let's also assume that this millimeter says centimeter. We can just ignore that part down there. But in any case, and yes, we're also going to want to assume that this ruler goes over to 16 centimeters just because it cuts off there. But in any case, let's imagine that we bring the pencil over here. How long is the pencil going to be? What can you report back? Well, notice that we have some really in-depth markings here. The centimeters go all the way to millimeters down here. And that means we can report quite a bit of information here, actually. So normally, since we have this split in the middle, normally we could do something like 15.99. But since we have these millimeters, we can actually go one in between those millimeters, and that gives us a bit more significant figures. So if I was to use this ruler to measure the pencil, I would report back 15.99. That's what we would do if we normally had the middle mark in here. But we actually have one more mark, which is the millimeter mark. So I'm going to say 15.99. Just because it's really close to 16, but I just personally don't think it makes it there. If you want, you could probably say 16.000 if that's your cup of tea. But yeah, so this is how you be honest when you're measuring a ruler in science, because you only have a certain amount of accuracy from these instruments, and you just want to report your numbers back very clearly. I'd like to move on to the second example of using significant figures, and that's of the blue water experiment that we actually did the second week of class here. So if you remember that experiment, we had a set amount of blue water and we put them into 3 different containers: a flask, a beaker, and a graduated cylinder. And we measured the amount of blue water in each of these objects, rather these containers, and report those back. So let's look at this flask first. So when we looked at this, we know that the total is 125 milliliters. And so we have to make an educated guess of how much blue water is in here. We don't have any markings on here, so it's going to be a bit tricky. But because of that, we can make a general estimate. And I think the estimate that we made was 70 milliliters here. And I think that's kind of reasonable looking at this flask here. But notice that we can't do something like 71 or 72. And the reason for that is that we don't have enough accuracy to be able to do something like that. We have to keep it to the whole number, to really one significant figure here. Let's move on to the beaker. I think for the purpose of this experiment, we excluded the middle marking here. So assuming that doesn't exist, how much can we report? Well, since we only have numbers like 80 and 100, we can only go between those. But we can go to the marking of 89, I believe it is, because that is in between, and we can go Or actually, rather, if we exclude the middle marking, we can only go to number like 90 or something like that, just because we can't go into that next significant figure. But if we do include these markings, then we can go to number like 89, because notice that this right here is 90, this right here is 89. We can go to something about right there, and that's perfectly reasonable. Alrighty. And the last one is a graduated cylinder. We can go to 83.0 because we not only have the middle marking, we have an additional marking here, which allows us to go one more step in. And so that's just another example. It's just really important to report back your numbers accurately when doing chemistry projects, experiments, labs, or even just science in general, because we can only report back what we know, and we can only know what we know based on the accuracy of our instruments. Thank you.